Let's solve these 4 questions one by one. All have been asked in UGC NET 2007. Let's start with this one. A primary key for an entity is, and they've given us 4 options, right? Candidate key, any attribute, super key, and unique attribute. Now, what is a primary key? A primary key is an attribute or a group of attributes which will help us to identify every row of the table uniquely. And how is a primary key derived? A primary key is derived from a set of candidate keys. What happens in the real life scenario is when the database is designed and the requirements analysis document is prepared, a set of functional dependencies are derived from it. And after the functional dependencies are derived, we generate, or the database designers generate, candidate keys. Now, out of those candidate keys, depending on the implementation that the designer wants, he or she chooses a primary key. And that primary key is used to identify every record in the table uniquely. And what is a super key? A super key is a primary key, or let's say a super key is a candidate key, to be more general. A super key is a candidate key along with some attributes. That means from a super key, if we are able to remove an attribute, we may still be able to identify every record in the table uniquely. Now, mind you, using a super key, we can also identify every record in our table uniquely. But the super key is not minimal. That means we could still remove some attributes from a super key and recognize records in our table uniquely. So, after this explanation, you can probably understand that a primary key for an entity is a candidate key. Right? Now, next one. Aggregate functions in SQL are, and they've given us 4 options. Just keep in mind that there are 5 aggregate functions in SQL. Sum, min, max, avg, and count. These 5 aggregate functions are present in SQL. What is an aggregate function? An aggregate function is an SQL function which works on a group of tuples or a group of rows at a time. Okay, so aggregate functions in SQL are sum, count, avg. Now coming to the next one. End of an SQL command is denoted by, and they've given us 4 options. Now this is a fact, you know. By default, the end of SQL command is denoted by semicolon. This is by default. If you want, you can change it, but if you leave it as it is, then you will use a semicolon to end off your SQL statements. Okay. Now coming to the last one, here they have said this is a fairly long question and probably a bit more challenging than the other 3. So let's have a closer look at this. If a relation is in 2NF and 3NF, what is NF? NF means normal form. So you have normalized your table and your table has been found to be in both second normal form as well as third normal form, right? Now, see, third normal form is more restrictive than second normal form. So if your table is in 3NF, then it is definitely in 2NF, right? Now, so if a relation is in 2NF and 3NF, then these 4 options are given. Now let's examine each and every option carefully. The first one says, no non-prime attribute is functionally dependent on other non-prime attributes. Okay, what is a non-prime attribute? A non-prime attribute is an attribute which is not part of our primary key. That means, let's say our primary key consists of 3 attributes. So if our primary key, let's say we have a primary key like this. We have a primary key A, B, C. This is our primary key. Okay. Now in ABC, which is our primary key, the key attributes are A, B, and C. So there are 3 key attributes in our primary key, A, B, and C. Let's say there are 3 more attributes in our relation. Those other 3 attributes which are not part of the primary key will be known as non-key attributes. Okay, so those will be known as non-key attributes. Now let's get back to the option. So no non-prime attribute is functionally dependent on non-prime attributes. Mind you, what does 2NF do is 2NF eliminates partial dependency. What is partial dependency? if a non-prime attribute is partially dependent on a key attribute, then it is said to possess partial dependency. And 2NF eliminates it. And what does 3NF do? 3NF eliminates transitive dependency. And what is a transitive dependency? A transitive dependency is when a non-prime attribute depends on another non-prime attribute. So here they've said that if a relation is in 2NF and 3NF, then no non-prime attribute is functionally dependent on other non-prime attributes, which is correct, because just now I mentioned that if a relation is in 3NF, then no non-prime attribute will depend on any other non-prime attribute. That means there will be no transitive dependency. So this option is absolutely correct. Now coming to the second one, no non-prime attribute is functionally dependent on prime attributes. See, this does not make any sense. Our attributes, the attributes that we'll have in our relation, they'll have to depend on the prime attributes. Otherwise, the relation will not be defined properly. So this option is incorrect. Now what about the third one? All attributes are functionally dependent. Now this need not be the case always. You know, this often happens. It often happens after decomposing a table into subtables. We find that there are a couple of attributes which are not part of any functional dependency. So this statement will not hold in all cases. So this is also incorrect. And what about the last one? Prime attribute is functionally dependent on all non-prime attributes, which is incorrect, right? Prime attributes, it should be the other way around. The non-prime attributes should depend on our prime attributes. Prime attributes are not supposed to depend on the non-prime attributes, isn't it? So this option is also incorrect. So we are left with only one correct option, that no non-prime attribute is functionally dependent on other non-prime attributes. Thank you.